Okay, so now we move on to example number 7 here. It says to write a rule describing the translation below. Now, when they say rule, what they're really talking about is that symbolic form, the arrow notation that we saw earlier. So what I want to do is look for the pre-image, and that would be this triangle here, DEF. Again, how do I know that's the pre-image? The vertices D, E, and F are just D, E, and F, whereas this triangle over here has those primes, D prime, E prime, and F prime, so that's my image, my after. Okay, so let's start with my pre-image, and again, I can pick any point. What I want to do is I want to know how many spaces this triangle shifted. I can see it moved to the right and up, but I need to know exactly how many spaces. So I'm going to pick a point in my pre-image and just kind of count and see how many spaces it went. So here we go. 1, 2, 3, 4, 5, 6, 7 spaces. So it moved to the right 7 spaces. Since it moved to the right, I know we should say it moved positive 7 spaces. And 1, 2, 3, 4, it moved up 4 spaces. So again, that must mean it went plus 4 because up was plus. So how do I write this rule? I'm going to be using arrow notation. So if you remember, I always start off with x comma y. And again, those represent the original pre-image points. And I put an arrow to show that something happened to it. In this case, all my x values, again, x left and right horizontal, that moves 7 spaces, so positive 7 spaces to the right. And the y value moved 4 spaces up, so that's plus 4. If it had went down, I would have wrote negative 4, right? So it moved up, so I said plus 4. And there we go. There is the rule to describe the translation below. Now, just to be certain here, I should count each of my vertices. For example, F and F prime should still be 7 spaces to the right and 4 spaces up. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. Right? So no matter which point I chose, it still would have been 7 spaces up and to the right and 4 spaces up. Okay? All right. So there we go. Let's take a look at this one now, number 8. Again, we're writing a rule to describe the translation below. And I've got this quadrilateral. Again, identify which one is the pre-image. Well, that would be M, N, P, and O. And then my post-image, or image, would be this, M prime, N prime, O prime, P prime. So let's see how many spaces it moved. I can see it went left and up, but again, I want to be certain, so I'm going to take a point, any point. I'll take N, for example. Here's my pre-image. And let's see, 1, 2, 3, 4. So it moved 4 spaces left. If you remember left, that means we went negative 4 spaces. And then up 1, 2 spaces. So that's a positive 2. So my rule, my symbolic form should be x comma y, coordinates, arrow, and the new coordinates, x moved 4 spaces left, so that's a minus 4, and y went 2 spaces up, so that's a plus 2. And again, I can always verify I could have chose any point, like P, for example, and see it still moved 4 spaces left and 2 spaces up. So it didn't matter which of these points you chose to count, it should still be the same. And that's because these images are congruent to each other.